Okay, I think we're doing it right now. All right, so let's go to Notability. And let's review something real quick. Remember, we have equal, and we have congruent. And it's important to understand the difference. Okay, equal means the same amount. Okay, and you're taking these notes because you weren't in class. If you were already in class, don't worry about it. But if you aren't in class, take these notes, take a picture of them at the end, and hand them in. Okay, equal is the same amount. Congruent is the same size. So if we're referring to the figure itself, we're doing congruency. If we're doing how big the figure is, we're doing the same amount, quantity, numbers. Okay, so all those properties of equality that we learned right here, they also work for congruency. So for any segment AB, line segment AB is congruent to line segment AB. Okay. They look in the mirror and they see each other. They're the same size. Okay. If line segment AB is congruent, the same size as line segment CD, then we can flip it. The flip-flop, right? Line segment CD is the same size, is congruent to AB. Okay, they flipped it. Go swimming in the pool. Flip-flop, right? Like the fish. Okay, transitive property. If line segment AB is congruent to line segment CD, and line segment CD is congruent to line segment EF, then, see, here's the train with the connector. Then line segment AB is congruent to line segment EF. Boom. Okay. Properties of congruency work just like the properties of equality, which we've already gone over. Okay, here's the definition of congruency. Okay, segments are congruent if and only if they have the same measure. So, if AB is congruent to line segment CD, then the measure of AB equals the measure of CD. And that makes sense, right? I mean, think about the desk. Our two desktops, right? They're both the same size. They both have the same area. And then guess what? It works if you reverse it. Da-da-da-da. If AB is equal, if their measures are equal, then they are congruent line segments. Ta-da. Okay, so you use the definition of congruency when we change from an equal to a or back and forth, either way. Okay, definition of midpoint, we've had this. Divides it into two pieces. So if M is the midpoint of AB, remember we can draw that A, B, and M is right in the middle. Then we know that the measure of AM, the measure of AM is equal to the measure of MB. Da-da-da-da. Okay. And then the segment addition postulate, we've had this one too. This is the part plus the part equals the total. Okay, we've done this one before too. Okay. So the measure of AB plus the measure of BC equals the whole thing AC. And that makes sense. Okay. So these are just some of the fancy ways of saying what we already know. All right, so what you need to do is take a picture of this and turn it in your buzz.